Pluto, a name that once symbolized the outermost reaches of our solar system, a frontier beyond which lay the unknown. Discovered in 1930 by Clyde Tombaugh, Pluto captured the imagination of astronomers and the public alike. For decades, it stood as the ninth planet, a distant outlier in our solar family. Its small size, frigid temperatures, and mysterious nature made it an object of fascination. Yet despite its diminutive stature, Pluto held a special place in our understanding of the cosmos until 2006, when the International Astronomical Union, IAU, made a controversial decision that would forever change how we perceive this distant world. The reclassification of Pluto as a dwarf planet sent shockwaves through the astronomical community and beyond. Suddenly, Pluto was no longer considered one of the major planets in our solar system. Instead, it was placed in a new category, alongside other small bodies in the Kuiper Belt, a region of the solar system beyond Neptune filled with icy objects and remnants from the solar system's formation. This decision sparked heated debates, with some scientists and enthusiasts feeling that Pluto's unique characteristics warranted its continued recognition as a planet. Others argued that the reclassification was a necessary step to bring clarity and consistency to how we define planets in our ever-expanding understanding of the universe. But the story of Pluto doesn't end with its demotion. In fact, the reclassification brought renewed attention to this enigmatic world, prompting new questions and investigations into its nature and behavior. One of the most intriguing questions that emerged from this re-examination was the possibility that Pluto, with its highly eccentric and tilted orbit, could be on a collision course with Neptune. This idea has profound implications, not just for our understanding of Pluto and Neptune, but for the entire solar system. To fully appreciate the gravity of this potential collision, we must first understand the unique characteristics of Pluto's orbit. Unlike the nearly circular orbits of the 8 recognized planets, Pluto's orbit is highly elliptical. This means that its distance from the Sun varies dramatically over the course of its 248-year journey. At its closest approach, known as perihelion, Pluto comes inside the orbit of Neptune, making it closer to the Sun than the 8th planet. However, despite this close encounter, Pluto and Neptune have never collided, a fact that has puzzled scientists for decades. The reason for this lies in a complex gravitational dance known as orbital resonance. Pluto and Neptune are locked in a 3.2 resonance, meaning that for every 3 orbits Pluto completes around the Sun, Neptune completes exactly 2. This resonance prevents the two bodies from ever coming too close to each other. It's as if they are participating in a cosmic ballet, where their movements are perfectly timed to avoid a catastrophic collision. This delicate balance is maintained by the gravitational forces exerted by both planets, as well as by the Sun and other bodies in the solar system. But this balance is not guaranteed to last forever. Over long periods of time, even the smallest perturbations, caused by passing stars, the gravitational influence of other planets, or even the collective mass of the Kuiper Belt, could alter Pluto's orbit. Such changes, while seemingly minor, could have significant consequences over millions or billions of years. It's these small, cumulative effects that raise the possibility of a future collision between Pluto and Neptune, a scenario that, while unlikely in the near future, cannot be entirely ruled out. The potential consequences of such a collision are staggering. Neptune, the 4th largest planet in the solar system, is a gas giant with a mass 17 times that of Earth. Pluto, by contrast, is much smaller, about 1/6 the width of Earth, and with a mass less than 1% of that of Neptune. Yet despite its small size, a collision with Neptune would unleash a tremendous amount of energy. The impact could shatter Pluto, sending fragments across the solar system. Some of these fragments might be captured by Neptune's gravity, forming new moons or rings. Others could be flung out into interstellar space, or even sent hurtling toward the inner solar system, posing a potential threat to other planets and moons. The aftermath of such a collision would be a dramatic event, not just for our solar system, but for our understanding of planetary dynamics. It would provide a rare opportunity to observe the processes of planetary formation and destruction in real time, a phenomenon that is thought to have played a significant role in the early history of our solar system. Observing such an event could yield valuable insights into the forces that shape planetary systems. helping scientists refine their models and predictions of planetary evolution. But why haven't we observed such collisions before? The answer lies in the vastness of space and the immense timescales involved. Our solar system is incredibly old, over 4.5 billion years, and the processes that govern planetary orbits operate over equally immense periods. Collisions between major planets are extremely rare, and the chances of such an event occurring during the relatively short span of human observation are slim. However, the possibility remains, and it is a reminder of the dynamic and ever-changing nature of our solar system. The potential collision between Pluto and Neptune also raises important philosophical questions about our place in the universe. For centuries, humanity has looked to the stars and planets for guidance, inspiration, and understanding. The movements of celestial bodies have been seen as predictable, orderly, and stable, a reflection of a universe governed by consistent and unchanging laws. Yet the more we learn about the cosmos, the more we realize that it is a place of chaos, unpredictability, and constant change. The potential collision between Pluto and Neptune challenges our assumptions about the stability of the solar system, reminding us that even the most seemingly secure systems are subject to change. This uncertainty is a central theme in the work of modern astronomers and physicists, who grapple with the complexities of celestial mechanics and the unpredictable nature of gravitational interactions. Neil deGrasse Tyson, one of the most prominent voices in contemporary astronomy, has often spoken about the need to embrace the uncertainties of the universe. Tyson, who played a key role in the reclassification of Pluto, has argued that Pluto's demotion was not just a matter of redefining a planet, but a recognition of the complexities and nuances of celestial bodies. To Tyson, Pluto's erratic orbit and potential collision with Neptune are symbols of the mysteries that still lie beyond our current understanding. Reminders that the universe is far more complex and dynamic than we often assume. Meanwhile, Michio Kaku, a theoretical physicist known for his work on string theory and the future of space exploration, offers a different perspective. Kaku sees the potential collision between Pluto and Neptune not just as a threat, but as an opportunity, a chance to study the fundamental forces that govern the universe in unprecedented detail. Kaku suggests that by observing the gravitational waves and other phenomena produced by such a collision, scientists could test key predictions of string theory, gaining new insights into the nature of space, time, and the fundamental particles that make up our universe. Such an event could serve as a cosmic laboratory, offering a once-in-a-lifetime opportunity to study the building blocks of reality. As we contemplate the possibility of a Pluto-Neptune collision, we are reminded of the fragility of our solar system and the delicate balance that sustains it. The gravitational forces that keep planets in their orbits are incredibly powerful, yet they are also finely tuned and susceptible to disruption. The potential for a collision between two distant worlds highlights the interconnectedness of all celestial bodies, no matter how far apart they may seem. It is a reminder that in the vastness of space, everything is connected, and the actions of one body can have far-reaching consequences. But there is also a sense of awe and wonder in contemplating such a cosmic event. The possibility of witnessing a collision between two planets, an event that could reshape the solar system, invites us to look beyond our immediate concerns and consider the larger forces at play in the universe. It challenges us to think about the long-term future of our planet and our species, and to consider how we might navigate the challenges and opportunities that lie ahead. The story of Pluto and its potential collision with Neptune is more than just a tale of celestial mechanics. It is a story of exploration, discovery, and the unending quest to understand our place in the universe. It is a reminder that the universe is not a static and unchanging place, but a dynamic and ever-evolving system, filled with mysteries waiting to be uncovered. As we continue to explore the cosmos, Pluto's journey serves as a powerful symbol of the unpredictability and wonder of space, a reminder that the more we learn, the more there is to discover. So as we gaze up at the night sky and ponder the fate of Pluto, let us remember that we are part of something much larger than ourselves. The universe is vast, complex, and filled with possibilities, both known and unknown. And while we may never fully understand all the forces that govern the cosmos, we can take comfort in the fact that we are part of this grand cosmic dance, a dance that has been ongoing for billions of years and will continue for billions more. In the end, the journey of exploration and discovery is far from over. Each new discovery brings us closer to unlocking the secrets of the cosmos, and each step forward is a testament to the power of human curiosity and ingenuity. The story of Pluto and Neptune is still being written, and as we continue to observe and study their movements, we are reminded of the endless possibilities that await us in the vastness of space. The universe is a place of wonder, mystery, and infinite potential, and as long as we continue to explore it, we will always find new horizons to reach and new questions to answer. So, what will happen to Pluto and Neptune? Only time will tell, but one thing is certain: the journey to understanding the cosmos is one of the greatest adventures we will ever undertake.